Hello, LANDAU students. I am Miss Sara, and I would like to thank you for joining me to discover our amazing Earth through geography. The theme of this lesson is living on a dynamic Earth. Please pause the video to draw the graphics, take notes, and search for any words that you may not understand. As we first delve into geography, it is important to understand what the Earth is made of and how it works. The themes covered in this lesson are Our Earth from Within, where we will learn about what is beneath our feet. The second theme is From Continental Drift to Plate Tectonics. Here, we will learn about the movement of the Earth's crust. During our look at plate margins, we will see where the tectonic plates are and discuss how they move. In our final theme, we will take a look at the rock cycle and learn about how rocks change over time. What does the Earth look like inside? It may seem like the Earth is made up of one big rock, but it's really made up of a number of layers, sort of like an onion. These layers get more and more dense the closer to the center of the Earth you get. Take a look at the picture on the slide. The Earth consists of 4 main layers. These are the crust, mantle, outer core, and inner core. The crust is the thin outer layer of the Earth where we live. The next layer of the Earth is the mantle. The mantle is much thicker than the crust. Tectonic plates are a combination of the crust and the outer mantle. The core is located at the center of the Earth. The following slides will go into more detail and help you learn about the layers of the Earth. Take a look at this cross-section of the Earth. Here, you can see the different layers. I have added a couple of new words for you. The lithosphere is made up of a combination of the crust and the outer mantle. This is also called the tectonic plates. These plates are in constant slow motion and move on average a couple of inches a year. Where the plates touch each other is called a fault. When the plates move and the boundaries bump up against each other, it can cause an earthquake. The inner mantle contains the asthenosphere. The Earth's outer core is very hot. In fact, it is so hot that the iron and nickel metals it contains are liquid. The outer core is very important to the Earth as it creates something called a magnetic field. The magnetic field makes a protective barrier around the Earth's that shields us from the sun's damaging solar wind. The Earth's inner core is made up of iron and nickel, just like the outer core. The inner core is so deep within the Earth that it's under incredible pressure, so much pressure that even though it is hotter than the outer core, it is solid. The inner core is the hottest part of the Earth. Here is a table that defines the layers of the Earth. The crust is the Earth's surface on which we live. It is made of solid material. There are 2 different types of crust, continental crust and oceanic crust. The continental crust is composed of granitic, sedimentary, and metamorphic rocks. It can be up to 50 kilometers thick. The oceanic crust is composed of several layers. The topmost layer includes lavas made of basalt. It is between 5 and 10 kilometers thick. At the bottom of the crust, the temperature is about 870 degrees Celsius. The layer below the crust is the mantle. It is made up of the upper mantle and the lower mantle. The upper part of the upper mantle is about 100 kilometers thick and is solid. The maximum temperature is about 100 degrees Celsius. The crust and the upper mantle make up the lithosphere. It is the rigid outermost shell of the planet, almost like the shell of an egg, but a bit thicker. The asthenosphere is the denser, weaker layer beneath the lithospheric mantle. It is so hot that even though it is solid, it behaves as if it were plastic and can flow. The lower mantle is at a depth of 400 kilometers to 2,900 kilometers. It represents approximately 56% of the Earth's total volume. The temperature inside the lower mantle can reach up to 3,600 degrees Celsius. The outer core is made up of metals such as iron and nickel. It is liquid and responsible for Earth's magnetic field. As the Earth spins on its axis, the iron inside the liquid outer core moves around. The inner core is primarily a solid ball with a radius of about 1,200 kilometers. This is about 20% of the Earth's radius. It is the hottest part of the planet with a temperature exceeding 1,500 degrees Celsius.
Continental drift describes one of the earliest ways geologists thought continents moved over time. Today, the theory of continental drift has been replaced by the science of plate tectonics. The theory of continental drift is most associated with the scientist Alfred Wegener. In the early 20th century, Wegener published a paper explaining his theory that the continental landmasses were drifting across the Earth. He called this movement continental drift. Wegener was convinced that all of the Earth's continents were once part of an enormous single landmass called Pangaea.
About 3 million years ago, Earth didn't have 7 continents, but instead one massive supercontinent called Pangaea, which was surrounded by a single ocean called Panthalassa. The explanation for Pangaea's formation ushered in the modern theory of plate tectonics, which posits that the Earth's outer shell is broken up into several plates that slide over Earth's rocky shell, the mantle. Over the course of the planet's 3.5 billion year history, several supercontinents have formed and broken up, a result of churning and circulation in the Earth's mantle, which makes up most of the planet's volume. The breaking up and formation of supercontinents has dramatically altered the planet's history. So what is the evidence for continental drift? Besides the way the continents fit together, Wegener and his supporters collected a great deal of evidence for the continental drift hypothesis. Identical rocks of the same type and age are found on both sides of the Atlantic Ocean, for example. Mountain ranges with the same rock types, structure, and ages are now on opposite sides of the Atlantic Ocean. An example of this are the Appalachians of the eastern United States and Canada, and the mountain ranges in eastern Greenland, Ireland, Great Britain, and Norway. Ancient fossils of the same species of extinct plants and animals are also found in rocks of the same age but are on continents that are now widely separated. And grooves and rock deposits left by ancient glaciers are found today on different continents.
Plate margins are the point or place where two tectonic plates meet. We have 4 different kinds of plate margins on our Earth. We have constructive plate margins. These are margins that are moving away from one another. We have conservative plate margins. These are margins that are moving alongside of each other, either in the same direction at different speeds or in different directions and kind of rubbing along each other. We have destructive plate margins. That is where the oceanic plate goes underneath the continental plate. Usually at destructive margins, we do see volcanoes. And we have collision margins. And with collision margins, we usually tend to have mountain ranges. Plate margins, an in-depth view. The different plates that make up the crust of the Earth can move in 3 directions in relation to each other. They can either move apart from, towards, or past each other. The moving plates can cause earthquakes and volcanic eruptions. Constructive margins. When 2 plates move away from each other, the result is a gap that is continuously filled by lava coming from the inside of the Earth. As soon as the lava reaches the surface, it starts to cool and turns into solid rock. This process can be found, for example, in the middle of the Atlantic Ocean. Here, the lava has been building a vast submarine mountain range, the Mid-Atlantic Range. In places, this ridge can be high enough to reach above the surface of the water. This is how Iceland, a volcanic island, was formed. Such plate margins are constructive. New oceanic crust is created and the ocean grows. This process is called seafloor spreading. Conservative margins. The margins of the plates are not smooth, and that is why they often hook together when plates are sliding past each other. This creates enormous pressure. When the pressure gets too high, it can be released at once, and this can lead to violent earthquakes. There are no volcanic eruptions at these margins. They are called conservative margins. Here, the crust is neither destroyed nor created. The San Andreas Fault in California is the result of conservative margins. In 1989, a severe earthquake destroyed large parts of San Francisco. Unfortunately, San Francisco is located directly on the margin of two plates, which are sliding past each other. Destructive margins. In the process of seafloor spreading, new oceanic crust is created, but the Earth is not getting bigger. Therefore, crust has to be destroyed in other regions. This happens at destructive plate margins. They can be found wherever oceanic crust moves towards continental crust. This is the case, for example, near the Andes. Oceanic crust is denser and heavier than the continental crust, and it is therefore forced downwards. It sinks under the continental crust in the subduction zone. In the mantle, the sinking oceanic crust melts to magma, which may rise to the surface, creating volcanic eruptions. There may also be earthquakes. The Andes, a mountain range near the west coast of South America, is another result. While the plates move towards each other, the rim of the South American continent is compressed and folded into mountains. Collision margins are similar to destructive margins, except that they are made up of two continental plates that are colliding. These collision zones are not forcing one under the other. They are hitting one another and forcing the ground to come up, forming fold mountains, as just discussed with the Andes.
The rock cycle. The rock cycle is the long, slow journey of rocks down from Earth's surface and then back up again. Rocks often change during this process. During the rock cycle, rocks form deep in the earth, move and sometimes change, go up to the surface, and eventually return below ground. The three main kinds of rocks are igneous, sedimentary, and metamorphic. Each type of rock moves around the cycle in different ways. Sedimentary rocks are formed from pieces of other existing rock or organic material. There are three different types of sedimentary rocks: clastic, organic, and chemical. Metamorphic rocks are rocks that have been changed from their original form by immense heat or pressure. Igneous rocks, from the Latin word for fire, are formed when molten hot material such as lava cools and solidifies. The rock cycle is a never-ending process in which rocks continually shift and change over millions of years.
Summary. Lesson 1. Living on a dynamic Earth. Our Earth from within consists of four main layers called the crust, mantle, outer core, and inner core. Continental drift is a theory by Alfred Wegener about how the tectonic plates geographically moved from Pangaea to where they are today. We now know this to be plate tectonics. The theory of Pangaea can be proven by looking at land formation, vegetation, and the shapes of the continents. There are four types of plate margins. The rock cycle.